The mass of a substance, which follows a continuous exponential growth model, is being studied in a lab. The doubling time for the substance was observed to be 7 hours. There were 1.7 milligrams of the substance present at the beginning of the study. Let t be the time in hours since the beginning of the study, and let y be the amount of the substance at time t. Find a formula relating y to t. Use exact expressions. Do not use approximations. The key to this problem is actually use something called function notation. We're going to try to find a relationship between y of t and t. So we really want y of t, not just y. We're going to take this continuous exponential growth model. How do we translate that? Well, it's going to be y of t is equal to some initial amount. Let's call it y sub 0. And that's going to be e to the rate, or r, times the independent variable t. So there is our exponential growth model. We do know the doubling time is 7 hours. So if we put the doubling time, so that would be 2 times y sub 0 is equal to y sub 0 times e to the r times 7. Now we know y sub 0 is not 0. That's very important because we want to make sure we do not divide the entire size of the equation by 0. Now we get something nice. We get 2 is equal to e to the 7 times r. We're going to use the inverse function of the exponential function. So we're going to write the natural log of 2 is now equal to the natural log of e to the 7r. That means we have ln of 2 is equal to 7 times r. We now have found r. r is equal to 1/7 times the ln of 2. We want to go back and write our function. Our function is now y of t is equal to y sub 0 e to the r, which is 1/7 times ln of 2, multiplied by t. We actually do know y sub 0. Y sub 0 is equal to y of 0, which is 1.7. So finally, let's write our function to be 1.7 e to the 1/7 ln of 2 times our independent variable t. I'm going to circle this function, and we're going to use it for part B. How much will be present in 18 hours? In other words, how much of a substance will be present after 18 hours? That really just means find y of 22. So you take your function and you evaluate it at 22. 1.7 e to the 1/7. I'm going to take a shortcut here. Instead of saying 1/7, I'm going to say 22 over 7 times ln of 2. That is now 1.7 e ln of 2 raised to the 22 over 7. Now using log properties, we know what this expression equals to. 1.7 times base 2 raised to the 22 over 7. And you could easily type this into a calculator. Make sure you type the base 2 and the exponent first, because you got to do the order of operations. You get 1, 5, 0, 1, 5, 6, 1, 7, dot, dot, dot. And you want to make sure this number is actually more than the amount in the doubling time. So it should be more than what? Very likely more than the 3.4, and it is. We should answer the question in a complete sentence. After 18 hours, there is about 15 kilograms of the substance. It does say round to the nearest tenth, so I guess 15 and 0 tenths kilograms of the substance. So even though I circled final answers, make sure you're able to show your work. And what is the work that needs to be shown? Well, pretty much everything that's on this board here. So why don't we just circle the entire page?